Welcome to your second video about polynomials. You should have just watched one of our exponent properties. That's going to help a lot with this video. Alright, let's start first with the definition of a polynomial. This is a very mathy definition. But what I tell my students is to not be scared about math definitions, because if you break them down, you can understand more than maybe you realize. So let's look at a sum of terms. Alright, we know that means we're adding things together. Okay, terms are things that are added together. And we know what variables are. And we got x and y and z, things like that. Raised to a whole number exponent, okay? Whole number means, hopefully you remember, positive whole numbers or zero, right? So no fractions, no negatives on the variables, okay? Not talking about constants, but on variables. Okay, and then this parentheses part isn't really necessary because we already know that we can have no negative exponents, but we want to make sure that you're aware, no variables in each denominator. So this is not okay. But if we have something like 7x to the 5th plus 3x squared, that is okay. We got a sum of terms, we have a whole number, exponents, you can even have a constant at the end, even just 2x is a polynomial, right? Sum of terms, we could just always be like, okay, there you go, sum of terms. We don't have to have that. You can have one term that be a polynomial, you know, a monomial. So that's what a polynomial is. Let's talk about adding, subtracting, and multiplying polynomials. All right, adding is going to feel pretty familiar to you. Because look at this. I stole this from a different video, right? This principle of adding and subtraction requires like things. So all we're going to do is we're going to look for like terms. And like terms have the same variable and the same degree or the exponent on the variable. So if we're looking at these first two, add 7x to the third minus x plus 11. That's a trinomial. We're going to add it to 6x to the third minus 4. That's a binomial. We're going to look for like terms. So ones that have the same variable and the same exponent. There we go. 7x to the third plus 6x to the third. We're going to add the coefficients and keep the variable the same. Right? We're just adding them together, not adding exponents. Okay, next term, negative x. Sadly, the negative x stands alone. There are no other just x first degree terms. And then we'll look at our constants. 11 and minus 4, we can combine those to be plus 7. And that's all we do. 13x to the third minus x plus 7. There you go. Subtraction just has one more step because there is a sneaky little negative 1 here that needs distributed. We're going to subtract that whole trinomial at the end. We're going to need to distribute the negative 1. So that's our process here. First, distribute the minus, or you can treat it, if it helps you, like a negative 1. That helps some of your students as well. And then it's the same thing. We're just going to combine like terms again. So we'll distribute that first. The first one stays the same. And then that's going to make... Really, what this does is just changes the signs, right? Negative times negative becomes plus 4x squared. Distribute again. Negative times 3 is negative 3x. And then here is plus 5. And we're just combining like terms again. So 3x squared, 4x squared, that's 7x to the second power. 4x minus 3x is 1x. Or you can just write x if that is your preference. And then our constants, I always like to make the constants be in love. Oh, they're a little hard around them. Negative 7 plus 5 is negative 2. And again, that's all we can do. We can't combine any more like terms. So we're done. Adding, subtraction, just like terms. But multiplication gets a little bit trickier. Remember, with multiplication, just like we talked about before, it doesn't require like things. So we don't need to get those like terms or like even denominators, right? You just need to multiply. And you also want to remember from the last video, the product rule. Alright, let's put a little reminder of that. If I have x to the a times x to the b, I'm going to add the exponents together. Okay, that's going to be important. Here we have two binomials, right? Two terms each, and I'm going to multiply them together. And just like if I was going to multiply 52 times 13, The 3 goes to the 2 and the 5, and the 1, or really the 10, goes to the 2 and the 5. So the more important thing with multiplication is that every term from one polynomial or one set of parentheses gets multiplied with every term in the other polynomial or the other set of parentheses. So we're going to multiply this 3x is going to get multiplied to both the 4x and the negative 6y squared. So 3x times 4x is 12x squared. And then 3x times a negative, right? Treat that minus like it's a negative. 6y squared is negative 18xy squared. So already we've used the product rule in our first terms. 1 plus 1 is 2. But I couldn't do that in the second term because different bases. Then each term, right, needs to be multiplied from one polynomial to the other one. So we need to now do, let's switch colors for fun. We need to do the negative 4y to both of these. So negative 4y times 4x, negative 16. You can write yx or xy, doesn't matter. And then negative 4y times negative 6y squared is going to be positive 24. Okay, here's my 1 plus 2 is y to the third using that product rule. Okay, any like terms? Oh, sad, no like terms. If there were, we would combine them just like we did on the last slide. Okay, I can hear it now. Some of you are thinking about a specific word that starts with F. Okay, those of you who don't know what I'm talking about, that's very confusing for you. This guy, anybody thinking about the word foil? I don't like it. Neither does brother L, but we'll talk about why. But some of your students will come and they'll be like, I'm going to foil. So we will talk about it. Okay, F stands for first. Notice the first thing we did was we multiplied the first two terms. Let's do green. We multiplied the first two terms in each of those parentheses. So I multiplied 3x times 4x. That gave me my first term. Okay, O stands for outside or outer. The next thing I did, I was multiplied 3x again, but now with the other outside of the parentheses, negative 6y squared. And I got negative 18x, so y to the second. I'm going to run out of colors pretty soon. Let's do orange. Inside is our next one. All right, and so those were the two next to each other in the inside of the parentheses, and negative 4y times 4x. And that gave me negative 16xy. Okay, let's go with the dark blue. Last, you're going to look for the last two terms. So that's 4y and negative 4y and negative 6y squared. So this is great. It's very useful for keeping track of which two terms you've already multiplied, and to make sure that you get all four of them multiplied. And so it works, but only to an extent, which is why I don't like it. Let me show you what I mean. So first, right, FOIL. Okay, we know that. First, outside, inside, last. Keeps track. Works great for that problem we just did. However, what about that one? If I do first, outside, inside, last, this whole term gets missed. So sad for that term. Okay, and some people call it foiling, even though they do distribute to that one, right? I've also heard this called like the double rainbow, be a triple rainbow in this case. So that's why I don't like FOIL, because it doesn't always apply. There are other ways to think about multiplication that I'm going to show you right now that will be helpful. And maybe you learned one, or your student will know one. That's awesome. If you have a way that works, and that works for your students, go with it. First one I actually learned from a student, and I call it the box method. If you are familiar with like Punnett squares in heredity, it's going to be similar to that. You're going to take one of them and write it alongside the box, each term getting one row, and then you're going to take the other one and you're going to write it on the top of the box, each term getting one column. And then inside the box, wherever those rows and columns meet, we're going to multiply. So negative 5x to the third times 6 is negative 30x to the third. And then I'll just go through that whole row. And I get here 20, adding the exponents, x to the fifth, and negative 5x to the fourth, adding those exponents. And then the second row, this will just change all those signs, because it's a negative 1. And from here, I combine the like terms. Man, I did not give you enough like terms in this video. So sad. I'm going to write in descending order just so I can keep track of them. 20x to the fifth, negative 5x to the fourth, minus 30x to the third, plus 4x squared, minus x minus 6. And that's our whole answer. It's the box method. A lot of students like this because it's a very organized way to see it. Some people don't. They like to just distribute. That's fine too. Last one I learned also from another student is super distribution. And what this student did, I'm just going to repeat this with the previous problem. Okay, we won't bother finishing it. But what they did is they wrote it out really as a distribution problem, because that's what it is. So they just took one term and put it in front of the whole second polynomial. And then did the same thing with the other one. Okay, some people like it this way. And then from there you can combine like terms once you're all done, if there are any, which they aren't in this problem. So 3 different ways to look at multiplication. The last thing we talk about with this polynomial operations is a warning for you. There are some things called special products that you might get wrong, or your students will most likely get wrong. A lot of them get confused. So the first one is this. Last video we said we can distribute exponents, but no more. Well, no, I can't do that, because if you distribute the exponent here, you get, oh, lovely, x squared plus 16. No, that's not what it is, because it's really x plus 4 times itself, right? Which if we FOIL or box method or super distribute it, it will have a middle term, which we completely missed just distributing the exponent. And we don't want to miss out on the middle term, make them feel left out. So if we multiply these, we get here in the middle 4x plus itself, and you get x squared plus 8x plus 16. So, don't do that. Don't just distribute it. Don't do that. I don't like it. You see how I'm very passionate about this? Don't forget the middle man there. Okay, another one that is a little bit tricky, but is actually one of my favorites, is this. Okay, a lot of people confuse it with problems like number 1. And so notice, yeah, they're very similar, but they are not exactly the same. So if we multiply these, 2y times 2y, you get 4y squared. 2y times 3, you get 6y. Negative 3 times 2y. Ooh, interesting. Negative 6y. And then here at the end, negative 3 times 3 is negative 9. What happens? Okay, I told you not to forget about the middleman, but he can leave, right? It's okay. He can just leave. He has his agency. But there's no middle term, and that's okay. And the reason that happens is when you have everything the same, it'll look something like this, except for those middle signs. 1 minus and 1 plus means you get just the first term squared minus the last term squared. Of course, a lot of you have heard of this before. This is a difference of squares, and it comes up a lot. Even if you're tutoring calculus, this is going to come up. And so it's really useful to know, no matter what level you're tutoring. All right, one more. This one isn't a special product per se, but you want to be aware of it, because again, just like number 1, we can't just distribute that exponent. And so what you're going to do when there's 3 polynomials, even if it's not to the third power, if there's just 3 of them, you want to take 2 at a time. So for example, if I have 3 times 5 times 7, I just take 2 of those, right? And then multiply. It doesn't matter which 2 I start with. So for problems like this on number 3, you're just going to take 2 of them. And then you'll worry about the third one after you have the result of the first 2. So we'll multiply these first 2, 3x times 3x, 9x squared, 3x times negative 5. And then just like in number 1, that's going to repeat again. So negative 15 plus negative 15, negative 30x plus 25. And then you'll multiply this way on that one. Okay, we're not going to face up just because of time, but if you want to know the answer, try it out yourself. This is what it should be. Ooh, you can even try the box method on this one. That'd be fun. Super distribution. Can't FOIL that. There's too many terms in the first one. But that's the answer you should get. You can check your answer. See how it goes. But that is the end of your polynomial videos. We talked about exponent rules in the last video and polynomials on this one. So go ahead and try that polynomials worksheet. Well done.